Welcome to Ganitika.com, a website for mathematics lovers, learners, and leaders. Many of you have requested to do past papers for International Baccalaureate DP Mathematics, Analysis and Approaches, higher level and standard level topics. And so in this video, I have taken up the topic sequences and series, which is SL topic. So it is also helpful for HL students. So this video is for both HL and SL students. In these videos, I will be giving you some tips then and there which will be helpful for you to tackle the questions in the examinations. I will be giving you some tips on using the calculator, on in time management, on reading the question and how to choose the correct method, etc. So there will be a lot of tips in between the solutions. And so watch carefully and take care of those tips. Before you start, you need to have this booklet in front of you. This can be easily printed from the website ibo.org. So you should have a printout of this booklet, which is Analysis and Approaches Formula booklet. So if you don't have this, pause the video here, get the printout and come back to the video. Because this is very important. You need to have this booklet and you need to familiarize with this booklet rather. So in the examination, this booklet will be given to you. And you should know what are the formulas that are available in this booklet for you to use in the examinations. So you cannot waste time in looking for the correct formula in this booklet. So during the course, during your homework, during your classwork, and during this past paper solutions, it is better that you familiarize with this booklet so that you will know exactly which topic has which formulas and which page to see for which formulas. So for example, if you want a formula for sequence and series, you will know exactly which page it is and what are the formulas that are under the sequence and series topic. So it is better to know everything before you go to the examinations, because this booklet will be given to you during your examinations. So get familiarized with this booklet first and have the copy of this booklet now in front of you before you proceed with this video. The next thing is that you need to have a notebook and a pen. I insist you have a pen and not a pencil. Using a pen actually increases your confidence. If you use pencil, you know that you can erase it and you can rewrite it. Therefore, your confidence level will be less and you will be making more mistakes because the mistakes are erasable. But when you use pen, you know that you cannot erase the mistakes and you cannot strike as often as you would do with the pencil, right? You will not like to see the striking of your answers on your notebook. So automatically your mistakes will get reduced. Eventually you will have very less number of errors in your working. So start using pen right now onwards. Stop using pencil. Pencils can be used only for graphings and tables. And another important tip that I wanted to give here is you are not supposed to use whiteouts during your examinations because whiteouts cannot be scanned. The next important thing that you need to have is a graphing calculator with you for paper 2 questions. You will keep this calculator aside for paper 1, but you will pick it up for paper 2. So it is better that you have a graphing calculator, whether it is Texas Instruments or Casio or any other model. Whatever model you are using, bring it out and keep it in front of you right now before you continue with this video. And another tip on calculators is that you see that your calculator is always charged fully. Usually students have the habit of not charging the calculators as much as they do for their cell phones. So treat this as your cell phone and charge it always and keep it ready for usage at any point of time. So keep it ready, fully charged always. So that's the tip for calculator. And another important thing that you need to have now is your active, functionable brain with you. Are you ready for the past paper questions now? Do you have your notebook, pen, calculator, booklet, everything with your active brain? Come on, let's go in and solve some paper 1 questions on sequences and series. Okay? I'll be giving you the question first. You can read the question carefully or take it down in your notebook, pause the video, try to solve it, and then continue with the video to check your answer. That will give you a better perception on the question. So take down this question on your notebook, try to solve this, and then come back to see the solution that I'm going to give you. While I'm giving you the solutions, I'll be giving you some tips so you can take those tips also in, which will be more helpful for you to tackle similar problems in your examinations. Are you ready? Have you taken this down in your notebook? Now let's read the question carefully and underline the important words. A geometric sequence is important. It's a geometric sequence, U1, U2, U3, etc., which means it is an infinite geometric sequence. And U1 value is given to be 27, sum to infinity is given to be 81 over 2. Now that we know that we are in sequences and series question, you take your formula booklet and open the page under sequence and series and keep it ready. And you can see that sum of an infinite geometric sequence S infinity is u1 over 1 minus r is given in the formula booklet for you. Can you identify that in your formula booklet? So let's write the formula that we are going to use. And then we'll write down what is given. See, I have not even gone to the question yet. I'm still in the first line of the question. I'm collecting the information. I'm going to write them down in mathematical terms. So I will first write what is sum to infinity from the formula booklet. And then I'll write whatever is given in the question. It's given that u1 is 27. It's also given that sum to infinity, which is now S infinity by notation, is equal to 81 over 2. So I'm just collecting the information and writing them in order. And then now I will connect them together. I'll see what is given. The question number A is find the common ratio of the geometric sequence. So let me connect what is given together. S infinity is 81 over 2 and the formula is u1 over 1 minus r. Therefore 81 over 2 is equal to 27 over 1 minus r. Rearranging this and simplifying for r, whichever way you want to rearrange, you can do this. There is no hard and fast rule what you need to do here. So this is 2 over 3. So r is equal to 1 over 3. So you must have got 1 over 3 for r when you solved it just a few minutes before. So this is the way you solve this first question A. How is it marked? It's for 2 marks, right? So this is method 1, which is method mark, which is given for applying the correct formula, not just writing the formula from the formula booklet. This method mark is only given when you apply the correct numbers into the correct formula. For example, 81 over 2 should be applied for S infinity, 27 should be applied for u1, and the formula that you should be using is S infinity is equal to u1 over 1 minus r. If all these things are correct, you will get that M1 mark, not just writing the formula from the formula booklet. Okay, the correct value should be substituted inside the formula, and that is when you will get this method mark. So there is one method mark for this, and whatever way you solve this for r equal to 1 over 3, it doesn't matter. You can solve this in any method you want, but the final answer matters here, which is carrying one answer mark. Therefore A1 for the final r value. So method marks are not given for copying the formula from the formula booklet. Let's move to the next part of this question. From geometric sequence, we are moving on to arithmetic sequence. In this arithmetic sequence is connected with the previous geometric sequence, because V2 of this arithmetic sequence, which is the term 2 of the arithmetic sequence, is the same as the second term U2 of the geometric sequence above, and similarly V2 is equal to U4. So what do we have now from the previous question? We have U1 is equal to 27 and R is equal to 1 over 3. We need to have U2 and U4. So let's find U2, U3 and U4 now using U1R, U1R square, U1R cubed. Now we know that V2 is equal to 9 because 9 is U2, and V4 is equal to 1 because U4 is 1. So we have these information from the first line that's given in the question. Let's read the question now. Find the greatest value of n such that this summation is greater than 0. What is this? Sigma n equal to 1 to capital N of Vn, which is nothing but the sum to capital N terms of the arithmetic sequence. So this has to be positive. In that case, what is the greatest value of n? This is the question. In order to find the sum to capital N terms, we need this formula from the formula booklet. So you need to open the formula booklet so that you know that this is the formula for Sn for arithmetic sequence, and rewrite this in terms of capital N. Instead of small n in the formula, replace the small n by capital N because we are finding the sum to capital N. So n over 2 times 2 V1, instead of U1, the term here is V1 times n minus 1 times D. So this is the formula that we are going to use. And for that we need V1 and D, and that can be found by these two information. V2 is V1 plus D, V4 is V1 plus 3D. So using these two information and making the simultaneous equations, you can solve these equations and get V1 and D. If you haven't done this before, when I gave you the time to do this question, you can pause the video here and solve these two simultaneous equations. So are you ready? This gives you D is equal to -4 and V1 is 13. So if you got this, you are right. So you have got V1 and D. You can straight away substitute in Sn. But before going to Sn, let's see what is given in the question. Question is asking for capital N for which Sn is greater than 0. So instead of greater than 0, let's use equal to 0 and solve for n. So pause here again, solve for n, substituting the value of 13 in the place of v1 and negative 4 in the place of d. Now you solve for n, simplify. So n will be either equal to 0 or n will be equal to 7.5. N cannot be equal to 0 because 0 is not the term. Actually 7.5 also cannot be possible because you cannot have the number of term to be 7.5. So you need to think a little bit at this point. Since d is equal to negative 4, we have this as a decreasing sequence. And it is also known that S 7.5 is at n equal to 7.5, Sn was equal to 0. So S 7.5 equal to 0, which is meaningless. Now what happens with this is, when you go back to 7th term, sum up to 7 terms will be positive and the sum up to 8th term will be negative, because at 7.5 it's going to be 0. So before 7.5 it will be positive, after 7.5 it will be negative. So S7 will be positive, S8 will be negative because it's a decreasing sequence. Therefore we are looking for S7 greater than 0. So the greatest value of n will be equal to 7. Let's go for the marking scheme. Finding the values of d and v1, a1 and a1 marks for each, and method 1 mark for using the correct formula for Sn and substituting the correct values for Sn. You can either use greater than 0 or equal to 0. It's left to you. If you use greater than 0, be careful. You will get n greater than 7.5. The value is not S8. It is S7. So you have to be careful. It is always comfortable to use equal to 0 and think whether it is a decreasing or increasing sequence. And accordingly you put whether the previous number or the later number after 7.5. So as you can see here, 7.5 is not rounded off to 8. It is the sequence characteristics that you need to think about before you actually give answers for these questions. So this is a tip that you are carrying. After getting the value for n, think about whether the sequence is increasing or decreasing, and look at the question whether you are asked for greater than 0 or less than 0. Accordingly, you choose the correct number before 7.5 or after 7.5. I hope you understood this tip. After getting that M1 mark for substituting the correct values into the formula, you have another M1 mark for choosing the correct number for n, and actually the correct number as such carries one A1 mark. Therefore, this is for 5 marks. I hope this question was quite simple for you. I've given you a lot of tips in this question. Please take them down. Let's proceed further. This question maximum mark is 4. The question is simply asking you to find the value of k for which the sum of k 1 over 3 power r is equal to 7. First of all, let's see what are the things that are given in the question. By looking at 1 over 3 power r, you can say that this is a geometric sequence, or a geometric series in fact. So 1 over 3 power r is a geometric series, and this infinity shows that it is a sum to infinity. So we have a geometric series for which you need to find the sum to infinity. So I am going to give you another tip here. Whenever the series is given in sigma form, the first thing that you need to do is expand the series so that you can clearly see the series in individual terms. For example, here in this case, r equal to 1 will give you the first term k times 1 over 3. R equal to 2 will give you k times 1 over 9. R equal to 3 will give you k times 1 over 27, etc. And this summation is equal to 7. So it's an infinite geometric series which is equal to 7. So it's always helpful to write the series in expanded form when it is given in sigma notation. So this is another tip. You need to take it down now. This will give you a better perception of the question. Now you can common out the k and write the infinite series in bracket equal to 7. What you are seeing inside this bracket is a sum to infinity of a geometric sequence where u1 is 1 over 3 and the ratio is also 1 over 3. And substituting this in the formula S infinity is equal to u1 over 1 minus r, which we just saw in the previous question. So again in this question for the examination, you need to refer to the formula booklet for S infinity formula. u1 over 1 minus r. u1 is 1 over 3. r is also 1 over 3. Substituting this and simplifying this, you will get S infinity, which is there inside the bracket, will be equal to half. Now this half will go with the equation that you have. So k times half, which is S infinity, will be equal to 7. So the equation is changed to k by 2 is equal to 7. Therefore k is equal to 14. Therefore you got this value for k by using the S infinity formula. Before you found the S infinity, you had to find u1 and r for the infinite sequence. and therefore finding u1 and r carries 1 mark each, and using the formula for s infinity and substituting the correct values inside them is a method mark, and the final answer mark for k will be 1a1 mark. So these are the things that you will have for this question. Next question. Pause the video here, write it down on your notebook. Try to solve this by yourself before you look into the solution that I am going to give you in few seconds. Are you ready? The question is the sum of the first n terms of a sequence. It's not given whether it is arithmetic or geometric, but what is given here is the sum of the first n terms of the sequence for which the Sn is given to be 3n square minus 2n. So let's write it down. Sn, which is the sum to n terms, is given to be 3n square minus 2n. The sum to n terms is given, not u1. Remember this carefully. Whenever you are given sum to n terms, what comes to your mind is S1 is equal to u1. Sum to first term is the first term itself. Sum to two terms is u1 plus u2. Sum of the first two terms. S3 will be u1 plus u2 plus u3. And S4 will be u1 plus u2 plus u3 plus u4. So write them all down. Think about what is the given information in this question. Now going to the question, find the value of u1. So it's very simple. You just wrote it down. S1 is equal to u1. Therefore u1 is nothing but S1. Sn formula is given. Substitute 1 in n. And then simplifying this, you will get u1 is equal to 1. That's it. Going to question B. It's very simple. It's just for 1 mark. Going to question B now. We need u6. Using Sn, how do you find u6? So finding the term from the sum of n terms is u6, for example, will be S6 minus S5. S6 is sum of 6 terms. S5 is sum of 5 terms. So subtracting them, you will get the 6th term, which is u6. So just simply substitute the 6 in Sn and 5 in Sn and subtract them. So you can simplify this in your notebook by pausing the video here. Then if you simplify, you will be getting the answer as 96 minus 65, which is 31. So the term 6th term in the sequence, whichever sequence it is, we are not sure whether it is geometric or arithmetic. But whatever the sequence is, we have that the 6th term of the sequence is 31. Let's proceed further with marking scheme here. First question A is just for 1 mark. So you will get A 1 mark for giving the correct answer there. And the second question B is for 2 marks. So you'll get a method mark for actually using S6 and S5 in the correct sense for getting U6. And then simplifying this correctly to get 31 for U6. This carries A1 mark. So 2 marks for question B. Let's proceed further to question C. Let's have this information S1 equal to U1, S2 equal to U1 plus U2, etc. ready with us. Now we need to prove that UN is an arithmetic sequence. So now we are going to show that UN is an arithmetic sequence. For that we need to find what is UN in general. UN in general is subtraction of nth sum minus n minus 1th sum, right? So Sn minus 1 as we did for U6, S6 minus S5. We have to expand it to the general form. UN is equal to Sn minus 1. Simply substitute the n values into the given expression and simplify. You will get this expression to be equal to 6n minus 5. So un is 6n minus 5. This is the nth term of the sequence. This is not enough. We have just found the nth term. We have to say that it has the same common difference in order to say it is an arithmetic sequence, correct? So for finding the common difference, you can use the formula un plus 1 minus un, which is the difference of two consecutive terms. You can also use un minus 1. In this case, n plus 1th term minus the nth term will give you the difference d. So substituting the values of n plus 1 and n in 6n minus 5 and simplifying, you will get the value for d to be 6, which is a constant. When the common difference is a constant, the sequence is arithmetic. So you can write that down in the last statement as a final statement. But we also have another method to solve the same question. Instead of finding un plus 1 minus un, you can expand the sequence u1, u2, u3, u4. Using that information, un is equal to 6n minus 5. Substituting the n values as 1, 2, 3, etc. You will get all the terms of the sequence 1, 7, 13, 19, 25, etc. Now find the difference for at least 3 or 4 consecutive terms, and you can see that all these differences are equal to 6 and they are the same. So in this case also, it shows that it is an arithmetic sequence. So you have proved this in two ways. You can use either general term un plus 1 minus u1, or you can expand the sequence and you use the sequence to identify that the common difference between at least 4 or 5 consecutive terms are the same. Now let's mark it. Using sn minus 1 to find un will give you 1 mark, and substituting the correct values and simplifying to 6n minus 5 will give you another 1 mark. And reason mark for using either of the two methods, either using the nth term method or expanding the sequence and finding the common difference. Basically, you need to be working out towards saying that the common difference is the same. If your working is going towards that direction, you will get this R1 mark, which is reason 1 mark. Then if you found the correct difference equal to 6, then you will get 1 A1 mark here. So there are 4 marks for this question. Here is the next question for you. So let's first solve question A here. It's an arithmetic sequence u1, u2, u3 where u1 is 1 and common difference is not given, but it is said that d is not equal to 0. So this is the information we have. Another information is also given here. Given that u2, u3 and u6 are the first 3 terms of a geometric sequence. So if I call the geometric sequence as g1, g2, g3, etc., u2 is g1, u3 is g2 and u6 is g3. So first thing we have is u1 is 1 and u2 is g1. Using the formula for u2, you will get u1 plus d for u2, right, from arithmetic sequence. So 1 plus d is u2 and that 1 plus d is given to be equal to g1 from the geometric sequence. So you make this equation first using u2 equal to g1. The next equation that's given is u3 is equal to g2. So the expansion for u3 in arithmetic sequence is 1 plus 2d. Expansion of g2 in geometric sequence is g1r. And the next step is u6 is given to be equal to the third term in the geometric sequence, which is g3. Expanding u6 and g3, you will get 1 plus 5d is equal to g1r square. These 3 equations are there. We have to solve them simultaneously to find the value of d. The question is finding the value of d. Solve for d using u2, u3 and u6 equations. So let's continue here. First of all, I will use u3 and u2. If you can see that u3 is 1 plus 2d equal to g1r, but g1 from u2 is 1 plus d. So I will replace g1 by 1 plus d from u2. So this is the new equation I am getting, connecting 1 plus 2d, 1 plus d and r. From u3 and u6, I will divide u6 by u3, which is 1 plus 5d over 1 plus 2d. g1 cancels there. R square over r gives you r. So we are getting the value of r to be 1 plus 5d over 1 plus 2d. I'll replace this in the previous equation and I'll get this equation. You can simplify this equation in any way you want. You can see that there is only d here in this equation. So when you solve this, you will get the value of t. So pause the video here. Solve this equation in whichever way you want. I'm going to show you a simple way where I'll multiply both the sides by 1 plus 2d. And if I expand both the sides and simplify, I will get the value for d to be equal to negative 2. I hope you also got this value. D is equal to negative 2 for question A. And now we will go for marking scheme. So the marking scheme will give you a method mark for identifying the 3 simultaneous equations from the given information. So even before reading the question, we need to rearrange the given information into mathematical form, and that actually carries a method mark. Next is trying to solve for d using the 3 simultaneous equations. So whichever way you want to use the 3 simultaneous equations to make the equation in terms of d alone will get you 1 method mark and 1 answer mark for getting the equation in d, and then final answer mark for actually finding the correct value for d. So the value for d here is negative 2, which will be the final answer for this question. So let's move on to the second part of the same question. It's given that u capital N is equal to negative 15. Remember, this is an arithmetic sequence. In the arithmetic sequence, it's given that the capital Nth term is negative 5. So again, just looking at this information, simplify this information into mathematical form. Okay. So un is nothing but, from the formula booklet, u1 plus n minus 1 times d, right? So you use that. We have that u1 is 1 and d is negative 2 just from the question A. So substitute the value of u1 and d in the formula and rewrite capital N as small n. So this is the equation in n. Simplify, you will get the value for n to be equal to 9. So this is the information. This is the final result you are getting from the information given. You haven't gone into the question yet, right? Now let's go to the question. We have the information that n is equal to 9. Keep it in mind. Go to the question. Determine the value of sigma r equal to 1 to n of ur. u1 plus u2 plus u3 all the way up to un. What is capital N? It's 9. So you can rewrite this now in this form. Replacing the capital N as 9. This is sum to 9 terms of the given sequence, right? Now use the formula. You have two formulas to use. One is n over 2 u1, 2u1 plus n minus 1 times d. The other one is n over 2 first term plus last term. Do you have first term and last term in this case? First term is 1. The last term is u9 and you have this u9 to be equal to negative 15 given in the question. So I will use that formula instead of the first formula. You can use both the formulas, that's okay. You could have used the first formula and you would have got the same answer, but it's slightly lengthier than this formula. So I'm going to use this formula now, and simplifying this, I will get this to be equal to negative 63. The value of sigma 1 to n ur is equal to negative 63, and this is the final answer for this question, which is really simple. I hope you got all the values here, which is A1 mark for getting the n value as 9 from the given information. You would have identified that simplifying the given information itself carries a method mark or an answer mark in every question, right? So first of all, read the question, get the general information, rewrite the general information as mathematical information, and see what all you can get from that given information, and then proceed to the question. And the next mark is M1 mark for using the SN formula correctly and substituting the correct values into the formula. And the final mark for the final answer, negative 63. 3 marks for this question, which is really simple. Let's go further for the next question. So first of all, what is given? Arithmetic sequence, U8 and S8. The 8th term and the sum to 8 terms both are same and they are equal to 8, right? I'm not going to go into the question yet, so I'll just see what is U8 and S8. U8 by the formula is U1 plus 7D. S8 by the formula is 8 by 2, 2U1 plus 7D. I'll use the first formula here. I can actually use the second formula also here, n by 2 U1 plus U8, because I know what is U8. I could use this formula as well. You can try to use both the formulas and see whether you are getting the same answer. In this case, I'm using the first formula, 2U1 plus 7D. Just in case if you had used this, you will be able to follow me. The first equation U8 is equal to 8 and the second equation is also equal to 8. So you have two equations to be solved simultaneously to find the value of U1 and D in this question. So solve these two simultaneous equations and then find the value of U1 and D. Shall we do that now? From this equation, I'm going to change 7D to 8 minus U1 and that 7D will be substituted in this place. Simplifying this, I'll be getting this, and simplifying this further, I'll get U1 to be equal to negative 6. I hope you also got the same answer in your notebook. Next, solving for D using U1 equal to negative 6, I'll get D is equal to 2. So we have done the question, completed the question. U1 is negative 6 and D is 2. It's a very simple question for 5 marks. So A1 mark for each of the equations that you have formed for U8 and S8. And then method mark for solving them simultaneously. Obviously, there is an answer mark for U1 and there is an answer mark for D. So very simple question and lot of marks in this question. So we are done with paper 1 questions. Now we are moving on to paper 2 questions on sequences and series. Are you ready for this? Are you really ready? Do you have this with you? The graphing calculator? Most of the students would forget that they have access to calculator for paper 2 and try to solve everything analytically and with hand, which is the major disadvantage in paper 2. So you will be losing lot of marks just because you forgot to use the calculator. See that you have this in your mind and right in front of you, always accessible. Because for every question, see how you can use this as efficient as possible. So be thorough with using the calculator for paper 2 questions. Are you ready now? We can go into the first question for paper 2. The sum of the first 16 terms of an arithmetic sequence is 212. The fifth term is 8. So which gives you S16 is equal to 212 and U5 is equal to 8. So this is the information we have. Can we decode this information into mathematical form as we do usually? So S16 and U5. U5 is U1 plus 4D. S16 is 8 times 2 U1 plus 15D using the formula from the formula booklet which we have used so many times today. Now this is equal to 8 for U5. S16 is given to be equal to 212. So you have two simultaneous equations. This is very common in sequence and series questions. You must have noticed that now. So be thorough with solving simultaneous equations. If you are not confident solving simultaneous equations, there are two videos in this channel, and the link for these videos are given in the description box below, and you can watch those videos for learning more about solving simultaneous equations. Now let's proceed with this question. So solving this simultaneously but not with hand, using GDC. So use GDC, simultaneous equation solver, from the menu algebra. Solve this and you can immediately get the values for D and U1, which is the first question. The first question A is find the first term U1 and the common difference D, and this is for 4 marks. So if you start solving the two simultaneous equations manually, it will take more time than 4 minutes. Therefore, using the GDC, it's going to be very quick. You will get the D and U1 immediately. And going for the marking scheme, writing U5 as an equation A1 mark, writing S16 as an equation A1 mark again, solving them using GDC, solving the simultaneous equation either using GDC or manual method, it doesn't matter, but solving them simultaneously is a method mark. But if you use GDC, you are going to save time. If you are going to do without GDC, you are going to waste your time in the examination hall. So use GDC efficiently here, and the final marks is for A1. Both D and U1. So there are 4 marks for this question and done in few seconds, right? Let's move on to question B. Find the smallest value of n such that the sum of the first n terms is greater than 600. So we have U1 equal to 2 and D equal to 1.5 from question A. Now we need to find the smallest value for what? For Sn greater than 600. Sum of the first n terms, Sn greater than 600. Now again we are going to inequality questions with Sn. So you need to think about Sn equal to 600, and then the next thing that you should come to mind is that D is positive, therefore it is an increasing sequence. Keep these two things in mind. You are going to solve for Sn equal to 600, and you are going to use the concept that the sequence given is increasing because D is positive. Keep this in your mind before you proceed to the next step. Going to the next step is using your formula booklet, writing down what is Sn using the information given. U1 is 2 and D is 1.5. Substitute that in the correct formula for Sn, which will give you method mark. We are going to see that soon. And once you have this equation, you can put this in GDC and you can solve for n is equal to 27.4. You can either use graph or n solver, and you can solve for n from this equation to be equal to 27.4. As you can see, this is a decimal number. You cannot have the nth term to be a decimal number. So you should go back to this information where you have 27.4 summation is 600, is equal to 600, right? So which will be more than 600 and which will be less than 600? This is an increasing sequence. The number before will be less than 600, the number after will be more than 600. Therefore 27th sum will be less than 600. Sum to 28 terms will be more than 600. We are going to see for more than 600, therefore the smallest value of n will be equal to 28, for which Sn is greater than 600. That should be your final answer, and not n equal to 27.4. Do not stop this question at n equal to 27.4. You will be losing a lot of marks in this. I am going to show you how many marks you will lose if you stop at n equal to 27.4. This is method mark using the correct Sn and substituting the correct values, and then using the GDC and solving for n. You are not going to get a mark for, as you can see, not for 27.4, but the last answer mark is for writing n equal to 28. So all the information that you have used from GDC to increasing sequence and then choosing the correct value for n as 28, all of them together will be A1 mark. So the final A1 mark is only for n equal to 28, not for n equal to 27.4. Hope you understood that. Be careful about it. Let's move on to the next question. Geometric sequence. First term is 4. Fourth term is negative 2.916. Of course, this is a calculator question, therefore the numbers are weird. What do you get from this? Let's make the simultaneous equations out of this. U1 is 4. U4 is therefore, it's a geometric sequence. Therefore, use the formula for geometric sequence. 4 times r cube. U4 is U1. U1 r cube is the formula for U4. And then this is equal to negative 2.916 given by the question. Therefore, you can immediately say from here onwards, even without looking at the question given for A, you can see that you can use GDC to solve for R as equal to 0.9, negative 0.9, which is the first question actually. Question A is find the common question A is find the common ratio of the sequence, which you have directly done by using U4 is equal to negative 2.916. Now let's go to question B. Question B is asking for sum to infinity. Formula for geometric sequence sum to infinity. This is it from the formula booklet. Write it down for safety sake. Now you know what is U1, you know what is R. Just simply substitute them and simplify. You can leave the answer as 4 over 1.9 to be very safe in fraction form. But if you want to use your calculator and simplify this, you need to give the final answer in 3 significant figures. So 2.11, if you are not writing this in 3 significant figures, you will lose the last A1 mark. So if you want to give the answer in decimal, the answer should be in 3 significant figures. Let's go for the marking scheme. Writing the A4 in terms of R and finding R using GDC carries 3 marks like this, A1, M1 and A1. And for B, using the correct formula and substituting the correct numbers into the formula and finding the last value, M1 and A1, just 2 marks for this. This is one of the simplest questions possible for sequences and series. So never miss such questions in your examinations and use GDC efficiently in these questions. Let's proceed to the next question. A geometric sequence has U4 is equal to negative 70. Geometric sequence U4 is U1 R cube is equal to negative 70. You can directly write it down. U7 is 8.75. Writing it down as the next equation, U1 R power 6 is 8.75. This is geometric sequence. So use the formula for geometric sequence. So this is your second equation. So you already got simultaneous equation. When you have a geometric sequence and simultaneous equation, divide the equations to get rid of U1 here. If you divide the second equation by the first equation, you will get the U1 cancelled and you will get R cubed in the left hand side. On the right hand side, you will get 8.75 divided by negative 70, and using your calculator, you can find what is R, and R is going to be negative 0.5. Is the question asking you to find R? No, it's actually asking you to find the second term. For that, you need the first term U1. So let's substitute R into this equation from the first equation and find U1 to be equal to 560. So we have U1, we have R, we need U2. U2 is U1R, correct? Substituting the values of U1 and R, you get this, and the value for U2 will be negative 280. Again, another simple question for 5 marks. The marking scheme would be method marks for making the 2 simultaneous equations, answer mark for getting the R cube value correctly, and final answer mark for using the GDC and getting the R value correctly. 3 marks for up to getting the R value. Then using the correct method for finding U1 and then substituting the correct value of U1 and finding the U2 will give you A1 mark here. So there are 5 marks for this. And this is very simple question again. So there is nothing much to show here, but the tip here is whenever you are dealing with geometric sequence simultaneous equation, you need to divide the equations instead of adding or subtracting as you would do for arithmetic sequence. Adding or subtracting would give you a more complicated equation in again 2 variables. So if you add or subtract, you will still have U1 and R in the equation. So you will not have anything cancelled. So if you want to cancel something in geometric sequence equations, you need to divide the equations so that U1 gets cancelled and you will be only left out with R values. So it's easy to find the R value in that way. Let's go to the next question. The third term of an arithmetic sequence is 1407, which means U3 is 1407, U10 is 1183. Making the simultaneous equations with this. Now I'm going to read the question. Find the first term and common difference, which is nothing but solving these 2 simultaneous equations. How will you solve them? Are we in paper 1? We are in paper 2. So GDC should come in. Use the GDC quickly and get the values for D as negative 32 and U1 as 1471. Very simple. It's for 4 marks. Quickly you can use GDC and get the answers. So going to the question B, calculate the number of positive terms in the sequence. So how many terms are positive? U1, U2, U3, U4, U5 and etc. How many terms are going to be positive? That's what you are going to say. UN. When is this UN going to be positive? Until when it's going to be positive. After certain stage, it's going to be negative because you see that D is a negative number. Therefore, it's a decreasing sequence. Therefore, eventually it will reach 0 at some point and then it starts becoming negative. So we need to find the number of positive terms for which the term is positive. So substituting the value for u1, un is greater than 0 can be rewritten as u1 plus n minus 1 d is greater than 0. Simply substitute the value of u1 and d. Simplify this inequality. Notice here I am not changing the inequality to equality in this case because this is just un, not Sn. So I don't need to change the inequality to equality. I can use inequality greater than 0 as it is and find the n value. Let's find the n value from this inequality. Be careful, you are multiplying n by negative 32. Therefore, this will change the inequality. N less than 1471 divided by 32 plus 1. Simplifying this using calculator, you will get n is less than 46.96 etc. Again, n is a decimal. We cannot use 46.96 as your final answer. You have to think about what type of answer you should give here. You are looking for when is n positive. For which value of n it will be positive. For all the values of n less than 46.96, it's going to be positive. That's what you have proved now. Therefore, the 47th value will be negative. Therefore, for n equal to 46, there are positive terms. Going for marking scheme, M1, A1 for simultaneous equations and solving it. Final answer for D, final answer for U1. For the first question, 4 marks, and for the second question, using the inequality correctly and substituting the values into UN formula correctly, method mark. A1 mark for finding the correct value for n in terms of decimals, and then changing that decimal to the correct number 46 carries 1 mark, A1 mark for this. So 3 marks for question B. Okay, let's go to the next question. Arithmetic sequence. First term 60, common difference negative 2.5. So you have taken down everything in terms of mathematical form. There is nothing to make any equations or simultaneous equation with the given information. So let's proceed to the question. Given that the kth term of the sequence is 0, find the value of k, which means in the sequence there is going to be a term which is equal to 0 because d is negative 2.5. It starts from 60 and it keeps decreasing by negative 2.5. And then eventually it will reach 0 at some point. When will this reach 0? It's very similar to the last question we did. We found when it is positive, but in this case we are going to find when it is going to be 0. So simply using the same formula uk, u1 plus k minus 1d, substituting the values for u1 and d, simplifying, you will get k is equal to 25. It's not a very difficult question, so I did it quite fast here. You can pause the video and try to understand this clearly. Do it on your notebook and proceed to question B. So question B also very easy here. Sn denote the sum of first n terms, which is obvious. Sn is always the sum to first n terms. Find the maximum value of Sn. Nothing is given. There is no information here. We need to first find what is Sn. So the formula for Sn will be n over 2, 2u1 plus n minus 1 times d. u1 is 60, d is negative 2.5. Substituting the correct information into the correct formula, you will get this. Now we are looking for the maximum value of this equation, of this function in fact. So this is a function, therefore use your GDC, graph this function. What graph will you draw? You will take f of x as Sn and n as x. So f of x is equal to x over 2 times 120 minus 2.5 times x minus 1 will be the function that you will input into the GDC. The graph will be an inverted quadratic graph, and what you are going to look for here is the value for Sn, which is going to be the maximum y value. So maximum value of Sn is nothing but the maximum y value in this function. So here you can see that the maximum y value is here and the value is 750.31, and if you want to give the maximum value for Sn, you will give it as 750 to 3 significant figures. Therefore, this is the final answer for you. Going for the marking scheme, this is mark method 1 and answer 1 mark, just 2 marks for the first question, which is very simple. You don't need to worry about this question. The next question is you need to write the correct equation in the correct form, Sn and n, substituting the correct value for u1 and d in the correct places. So you will have a method mark for this, and using the graph from GDC and finding the maximum y value will give another method marks. Getting the correct answer in 3 significant figures is another A1 mark. So 3 marks for this question. So this is very simple. You don't simplify the equation. Enter the function as it is from here. Don't waste your time in simplifying that expression. So enter it directly into the graph and then find the maximum y, which is very simple. It will not take more than 2 minutes to do this question. So we are done here with paper 2 questions. Thanks for watching. I hope this was very helpful for you. Contact me if you have any other questions on sequences and series. Happy learning from Ganitika.com. Meet you in the next video. Meanwhile, subscribe, like and share my videos with your friends and families. Thank you very much.